In this video, we're just going to talk about problem number 23 from the chapter 3 self-test. So it says a commodity has a demand function modeled by the price equal to 280 minus 4/10 times x, and a total cost function C is 80x plus 120, where x is the number of units of demand. And so our revenue function will be xp is 280x minus 0.4x squared. And that makes our profit function capital P equal to R minus C is 280x minus 0.4x squared minus 80x minus 120 will be a negative 0.4x squared plus 200x minus 120. So P prime will be negative 0.8x plus 200. So helping to answer the question, what price is going to yield maximum profit is what I'm trying to find here. So to maximize profit, we're going to find P prime, capital P prime, and set that equal to 0. Negative 0.8x is equal to negative 200. X is going to be 2,000 over 8 is 500 over 2 is 250 units. Now, that's not my answer because I need to find the price set for selling 250 units. $280 minus 0.4 times 250 should be at 100, I think. Yeah. So we should set that at $180. Now, part B asks us to find the average cost per unit. That would be 80 plus 120 over x when x is equal to 50. $82.40, and then when x is 650, just use my calculator for this one. $80.18 approximately. Part C is going to ask us to determine when the demand is elastic and unit elastic. So let's go ahead and give myself some space here for that. C is going to be, we need to find P over X. So that's 280 over X minus 0.4, and dP dx is going to be negative 0.4. So eta is going to be P over X over dP dx. Eta is going to be 280 over X minus 0.4 over negative 0.4. So eta is going to be plus 1. And this is a negative 700 over X, 280 divided by 0.4 is 700. And it's negative because a positive divided by a negative is a negative. So then I need to take the absolute value of eta. Is going to be the absolute value of negative 700 over X plus 1. And I need to set that equal to 1. So negative 700 over X plus 1 equals 1, or negative 700 over X plus 1 is equal to negative 1. And this doesn't work because I can't have negative 700 over X equals 0. So negative 700 over X equals negative 2 over 1. Negative 2X is equal to negative 700. X is equal to 350. So that will be where this is unit elastic. And then if, let's see, so X has to be between 0 and, I didn't figure that out, but 280 minus 0.4x equals 0. 0.4x equals negative 280. X equals 280 divided by 0.4 is 700. So X has to be in the interval of 0 to 700. And so we're going to be 0 to 350 will be a elastic situation, and 350 to 700 will be an inelastic situation. And if you want to find the derivative of the revenue and graph that and see that this is where dr dx is increasing, this is where it's flat, this is where it's decreasing. R is increasing, R is flat, R is decreasing. If I would do my first derivative test on my function R, I would get those same answers. So check yourself that way if you want to. And then it asks us for part D to use differentials to approximate the change in revenue as sales increase from 210 units to 220 units. So part D, we're going to start with the revenue equation. R equals 280x minus 0.4x squared dr dx is 280 minus 0.8x, which makes dr exactly 280 minus 0.8x dx, and makes delta r approximately 280 minus 0.8x delta x. X is equal to 210. Delta x is equal to 10. So delta r is approximately 280 minus 0.8 times 210 times 10. I get 1120. And so now let's figure out how close that was to what delta r is exactly. So that would be r of 220 minus r of 210 is equal to 280 times 220 minus 210 minus 0.4 times 220 squared minus 210 squared. 280 times 220 minus 210 minus 0.4 times 220 squared minus 210 squared is exactly 1080. So that's a difference of 1120 minus 1080. Difference of $40. All right. That's it for chapter 3. And we'll come back next time to start talking about chapter 4. See you for the next video.